This video lecture is about polar and non-polar covalent bonds, means polar and non-polar covalent compounds also. First of all, we need to learn that non-polar covalent compounds are those which have dipole moment equal to 0, and polar covalent compounds are those which have dipole moment greater than 0. What this dipole moment means? Take the example of diatomic molecules. Molecules that are consist of two atoms. We are first of all going to take the example of hydrogen molecule. In case of hydrogen molecule, we can see that at both sides we are having hydrogen whose electronegativity is 2.1, and in this case as well it is 2.1. So the tendency of both these atoms is absolutely equal to each other. They both attract electrons with equal force. So the shared pair of electron between them will be located at the very center. It will be tilted towards neither of these atoms. So because this electron pair is present at the very middle of these two atoms, therefore they both are having same amount of negative charge. They both are experiencing same electronic cloud. We will assume both of them to have neutral charges. Hydrogen in this case has 0 charge, and this hydrogen also has 0 charge. So the molecule which are consist of same type of atoms and they are having covalent bonds, they have very mutual sharing of electron. The electron shared pairs of electron are tilted towards no atom. They are present at the very middle, and therefore the overall electronic cloud distribution is very uniform, which provides the overall molecule 0 charge. The distribution of charge is here uniform. So this is actually a non-polar molecule. This is non-polar molecule, and similar will be the case of all those molecules that are consist of same types of atoms. So we can say that O2 is a non-polar molecule, and N2 is a non-polar molecule, F2, Cl2, Br2, I2, P4 and S8, all of them are non-polar molecules because they have mutual sharing of electrons. They all are similar, they are consist of similar atoms, and therefore sharing of electron is perfectly mutual. So there is no uneven distribution of electronic cloud. Therefore no formation of positive and negative centers takes place, and these all are actually perfectly non-polar molecules. The case of those diatomic molecules that are consist of dissimilar atoms, for example, if we take the diatomic molecules consist of different atoms. The example is of HF. Here in this case, hydrogen and fluorine are bonded together. The electronegativity of hydrogen is again 2.1, and electronegativity of fluorine is 4. So fluorine has greater ability to attract this shared pair of electron towards itself. Therefore this pair will be tilted towards fluorine, and therefore because electrons are negatively charged, this fluorine will experience a partial negative charge. It is partial because complete transfer of electron is not taking place. Electrons are still shared between these two atoms, but this sharing is actually unmutual due to the greater electronegativity of fluorine. And this hydrogen, on the other hand, will have a partial positive charge. So in this case, the dipole moment of the molecule, means the overall distribution of electron will be uneven, and the dipole moment will be greater than 0. Electronic cloud is moving from hydrogen to fluorine. In this direction electrons are moving. Dipole moment is greater than 0, so this molecule is actually a polar molecule. And like hydrogen fluoride, all other similar molecules that are diatomic but consist of dissimilar atoms, such as hydrogen chloride or hydrogen bromide or hydrogen iodide, or interhalogen compounds such as chlorine fluoride or bromine chloride or iodine chloride, etc. All are the molecules with dipole moment greater than 0, and they have polar character. So again, it is important to note that diatomic molecules that are consist of same atoms have non-polar character because of uniform distribution of electron, and because dipole moment in this case is 0, they are non-polar. And all the diatomic molecules that are consist of different atoms are polar in nature because of having dipole moment greater than 0. Then comes the case of those molecules which are consist of more than that they are consist of different atoms, and they are consist of more than two atoms, such as the case of carbon dioxide or sulfur dioxide or methane or ammonia or water or sulfur dichloride or tin chloride or boron fluoride, and the likewise molecules. We will discuss the case of these molecules in our next video. Thank you for watching, and stay in touch with us.